It has long been thought that when the ratio of the length and width of a rectangle is the golden ratio, then the observation of the rectangle is pleasing to the eye. We can see this ratio in Da Vinci's Mona Lisa, in the architecture of the Parthenon in Greece, and in the Great Pyramid of Giza. It is a subjective description to say that these things are pleasing to the eye, but this golden ratio can also be found in objects not made by humans. In particular, we can discover the golden ratio in the spiral patterns of sunflower seeds, seashells, and pine cones. One way we can discover the value of the golden ratio is to start with a rectangle of width 1 unit and length x units, where the unit of measurement is unimportant and x is larger than 1. When we mark a line inside this rectangle creating a square, with sides 1 unit and another rectangle where the longer side is 1 unit and the shorter side is x minus 1 units, we get the following image. We can set up a proportionality between the two rectangles by dividing the longest side by the shortest side. This gives us the following equation. X divided by 1 is equal to 1 divided by x minus 1. We can solve this equation by multiplying both sides by the least common multiple, x minus 1, and we get x times x minus 1 is equal to 1. This leads us to the quadratic equation x squared minus x minus 1 equals 0. Using the quadratic formula, we get the following solutions. X equal to 1 plus the square root of 5 divided by 2, and x equal to 1 minus the square root of 5 divided by 2. However, since x is the side of a rectangle, we cannot consider 1 minus the square root of 5 divided by 2 as a solution, since square root of 5 is greater than 1, making 1 minus square root of 5 divided by 2 negative. Thus, the only positive solution for x is 1 plus the square root of 5 divided by 2. And if we take the ratio of sides from the original rectangle, x divided by 1, we find that the value of the golden ratio is 1 plus the square root of 5 divided by 2. This is a number that has a long history, and similar to the ratio of the circumference and diameter of a circle being denoted by the Greek letter pi, the golden ratio is denoted with phi. We can use a calculator to find the decimal representation. As you can see, the golden ratio is also like pi in that it is an irrational number. Another interesting thing to mention is back at the proportionality we started with, x divided by 1 equal to 1 divided by x minus 1. If we reciprocate both sides, we end up with the proportionality 1 divided by x equal to x minus 1. Remember that the only positive solution for this was phi equal to 1 plus the square root of 5 divided by 2, which means that 1 divided by phi is equal to phi minus 1, or the reciprocal of the golden ratio is equal to the golden ratio minus 1. You can try this for yourself with a calculator by taking the decimal version of the golden ratio we found and then reciprocating using the 1 divided by x button. This result is the same thing as just subtracting 1 from the golden ratio. The value of 1 over phi plays an important part in the appearance of the golden ratio in nature and in art. In some classical musical compositions, the composers placed the climactic moment of transition from one movement to another at the phi point, or at approximately 62% of the way through the piece. One particular piece that this appears in is Beethoven's Fifth Symphony in the first movement. Whether this was because he found it pleasing to the ear or by design is uncertain. However, even modern compositions could be influenced by the idea of a climactic moment happening 62% of the way through the song. For example, the Beatles' In My Life is 146 seconds long, and the bridge happens at 88 seconds. When we divide 88 by 146, we get 60%, which is almost the phi point of the song. The song structure of this song is A-B, A-B, C-B, where A is the verse, B is the chorus, and C is the bridge. And in most song structures, the bridge is seen as a climactic moment to the song. This is a very popular song structure heard in most popular music even today. For example,